Hello.
Yes, sir. Good morning, sir.
Good morning. In the previous class, we have seen manipulating the main thread, accessing the information related to the main thread, right? So now we'll see how to create new threads other than the main thread. So there are two ways in which you can create threads, new threads in your program. First one is by creating a class that implements runnable interface. There is an interface called runnable interface, which I told you earlier also. Second one is by creating a class that extends that class. Okay. So we have already seen some information related to thread class in the previous program. Some methods also we have listed, and some of them we have used in the program also, right? So there are two ways in which you can create a new thread other than the main thread. First one is by creating a class. We need to create a class and make it implement the runnable interface. So you need to know what methods are defined in this runnable interface. So that why? Because when a class implements an interface, we need to give the definition for all those abstract methods that are part of that interface, right? So we should also know about those methods so that we can write the program and implement those methods in the class that implements runnable interface. And secondly, the second case is we have to create a class and make it a subclass for the thread class, right? Automatically, all the methods that are defined in the thread class will also be members of the class that you are creating newly in your program. So we'll see that next. First, we'll start with uh, implementing runnable interface. So in the most general sense, you create a thread by instantiating an object of type thread. But Java defines two ways in which this can be accomplished. You can implement the runnable interface or you can extend the thread class, as I told you just before. So when you implement a runnable interface, how the steps have to be taken. That means what are the steps you need to follow. You can construct a thread on any object that implements runnable interface. To implement runnable, a class need only implement a single method called run, which is declared like this. That means what? This runnable interface has a method called run method, which has a type signature like this, public void run. And inside run, you will define the code that constitutes the new thread. So by creating a new thread, what you're going to do is generally every program has a main method. Right? So whenever we start executing this main method, and from there we call any other methods also that will become part of the main thread. But when we create a new class and implement runnable interface and create a run method inside that class, then automatically another thread will start, and whatever code is written inside that run method, that will constitute the new thread that is created apart from the main thread. In that way, how many run methods you're going to create, how many classes you're going to create and implement runnable interface and define the run method in that classes, that many threads will be created. Right? So if I create three classes, say for example, and make all three classes either implementing the runnable interface or extending the thread class, whatever may be the case. And in all those classes, I have to define the run method, and the code that is written inside that run method will be constituting the new threads part. Because what is the important feature of this multi-threading, or the benefit of the multi-threading is your program is the entire large program is divided into multiple tasks, and each task is given to a different thread. Instead of giving the complete task for a single main thread, we are going to divide the entire task into multiple small tasks, and each of the small task is assigned to a separate thread. Right? We can, for example, in a single program, you want to find out you want to perform different operations like arithmetic operations like addition, subtraction, multiplication, division. Then you can divide 4 different threads apart from the main thread. One task of performing addition operation you can give to one thread. Performing division you can give for another thread. Multiplication for another thread, and the difference or the subtraction can be assigned to another thread. So in that way you can divide the entire single large task into small task and assign to different threads. Right. So as such, now we are going to see one example program where we are going to create one new thread apart from the main thread, and that new thread will have a different piece of code which performs a different operation, and main method or the main thread will have a different set of operations to be performed. Right. So let us see how to do this. So look at this program. At the beginning in the document I have mentioned creating a second thread. Second thread in the sense what? The first thread is the main thread. Every program will have at least one thread, right? And that if there is only one thread, then that thread must be a main thread. So apart from that main thread, if you want to create a second thread that is new thread, then how to do that? Using runnable interface that we are going to see in this program. So I'm defining a class called new thread and making it implement a runnable interface, right? So as I told you earlier, when you implement this runnable interface, what is that method we need to give the definition for? This runnable interface has a declaration for this method called public void run. So we need to give the implement that method here in this class because it is implementing that runnable interface, right? Apart from that, I'm also creating a constructor for this new thread class. Okay, and before the constructor is defined, I'm creating a reference variable for a thread class t. So now this t is not representing any of the threads. It is just a reference variable, right? Then in the constructor to create the new thread, what I am doing is I'm using the same reference variable t here that is declared here. T is equal to new operator and thread class. So this thread class has a constructor with 2 parameters. The first parameter is this keyword, and second parameter is a uh, description that you want to give or name that you want to give to the thread that you are newly creating, right? So it is the name that you can assign to the thread. So just like in the previous program, we have seen the name of the main thread is given as main, right? So now we are creating our own thread, the second thread. So when you create your own thread, you can give a name for the thread also. So whatever name you want to give to the newly created thread, that you need to pass as a string parameter as a second parameter to this constructor thread. And the first one refers to this keyword. This will refer to whichever thread you are creating. So when this thread will be instantiated means whenever you create an object for this new thread class, it will be instantiated. So later in my program, I'm going to create an object for this new thread class, and when I create that object, automatically this constructor will be called because this is the default constructor. And when I use this keyword here, this refers to whichever object you're creating for the new thread. That means what? Yeah, this T is going to refer to a new object that you're creating uh, later in your program, and that is going to represent the newly created thread. Okay. So that is why I'm using this keyword, and this must be as passed as first parameter to this constructor class thread. So now once this is done, this T is going to represent one newly created thread, right? Then I am displaying the child create the newly created thread information concatenated with the object T. So what is this going to do? This is going to display the output like this, just like we have seen in the previous program's output thread, and in the square brackets the name of the thread will be displayed. And because we didn't assign any priority to our thread, the default priority will be assigned, that is 5, and this will belong to the main thread. So all the new threads that we are going to create, they will belong to the main thread only. Why? Because we are creating all these threads from within the main thread. If you are creating a thread from another thread, say, then that will belong to another thread group. But we are not creating threads from other threads. We are creating from the main thread. So in all our example programs that we are going to see, all our threads will belong to the same group, that is a main thread group. Okay. So this will be the output displayed. Then after this, we need to make a call to the method called start method. So where is the start method defined? We have listed some of the methods which are part of the thread class. So in that thread class, we have a method called start, right? So already you have created a thread object T here. So using that thread object T, you make a call to that start method. Then what is the start method going to do is, it is going to make a call to the run method. So we need not call the run method exclusively in our program. We need to make a call to the start method. Then the start method will in turn make a call to the run method automatically. So that's why nowhere in our program we are going to make a call to run method, right? Then what is there in the run method means, I'm creating a try catch block as we have done in the previous main thread program. And within the try block, same for loop is used, and we are displaying child thread concatenated with the value of I, the loop control variable I. So this loop will repeat how many times? 5 times, and it will display the value of I starting from 5 to 1. And after every iteration, after displaying the child thread's value 5, 4, 3, each after every iteration, thread will be suspended for 500 milliseconds. That means half a second. Okay. Then this catch block is normal. So as usual, and after the catch block, I am displaying a message exiting child thread. So when you will come to this statement, only after you complete all the iterations of the for loop. And once this run method's definition is completed, it indicates that the thread that is newly created has completed its execution and it is going to exit. So that's the reason why in the last line we are displaying this information exiting child. But what is going to happen? Are we going to execute all these iterations of this for loop continuously without any interruption? Because now we have another thread, main thread also. Generally, main thread will be the first thread, the parent thread, and we are creating a child thread here. Right? So two threads will be there in our program. And coming to this class definition, the first class definition, that is new thread class definition, is completed till here. Then I'm defining another thread class thread demo, in which I'm defining the main method. Right? So in the main method, we are creating a object for the new thread class. Right? So whenever you create an instance like this, I'm not using any reference variable. There is no assignment operator. Generally, how do you create a thread? You create a thread like this, right? New thread. Say object name is given as NT is equal to new thread like this. You have to create. But I'm not using this left hand side portion which is on the left hand side of the assignment object, because uh, when I have to do like this is when I have some methods which I need to call them with this object, but I don't call this run method using this object here, because the run method will be called by the start method. And who is calling the start method? The constructor for new thread itself is directly making a call to the start method. So there is no need for me to create an instance variable like this. Directly instantiate that object like this so that the constructor will be automatically invoked. So whenever you write this new and this constructor here, the constructor will be automatically called. The constructor will call the start method, and start method in turn will call the run method. So is there a requirement for us to have a reference variable NT? There is no requirement. So when there is no such requirement, Java allows you to write a statement like this. So that is the reason why we are writing only the right hand side portion of the object creation for the new thread class. So whenever this new thread instance is created, automatically the constructor gets executed, and this T is going to be created with its name as demo thread, and this keyword refers to what instance that we are creating here, whatever instance we are creating here. So that is nothing but going to be referred by the this keyword. So this thread T now represents whatever thread we created here. Now the object that we created, that is going to be representing a new thread by using this object name T here. So that will call the start method. Before calling the start method, this will display the information about the child thread. That is, the name of the thread is demo thread, priority is 5, and group is, and then it will make a call to start, and start will make a call to run method. So that means what? From the main method, the program execution begins from the main method. So that means you are starting the execution from with the main thread, and the main thread is creating a new thread by making a call to the state. So that means what? A child thread is created from the main thread. So main is a parent thread, and the new thread demo thread that you are creating is a child thread. Okay. So when this is called, uh, automatically this run method starts executing and the child thread starts executing. But the child thread is being suspended, right? So along with that creation of the new thread, I'm writing the same try catch block even here also in the main thread also using the same for loop. But instead, this for loop will display information about main thread. And this main thread is being suspended for 1000 milliseconds. That means 1 second, where the child thread is being suspended for only half a second. This is being suspended for 1 second. And after the catch block, because once the main method definition is completed, it indicates that the main thread has been completed. So at the end, I'm displaying a message main thread exiting, just like I've done for child thread exiting child thread. So here also I'm displaying a message main thread exiting, right? So I'll tell you why the thread sleep method is called in the main thread for 1000 milliseconds, and in the child thread it has been called only for half a second, that is 500 milliseconds. So let me first execute this program and show it to you, then you'll understand. See, so first the execution begins from the main thread, and the main thread will create a child thread. And when the child thread is created, child thread takes control and starts executing and displaying the output like this. First, it will display child thread, which is defined in the this statement is the output. This output is given by the statement in the new thread constructor. right? Because the constructor is called soon after the main method starts its execution, it is creating an instance for new thread class, and the constructor gets called, and a child thread is created here, right? And then its information is displayed, and then it will make a call to start method. Start method will make a call to run method. So it is displaying first the child thread information as demo thread, priority as 5, and the group as main. Then after that again, you're coming back to the main thread, because child thread will the processor, the CPU will be switching between the two threads. So that is the concept of multi-threading, right? So you will have two different points of execution, and both these points of execution will be switching. The CPU will be switching between them. So once the child thread has completed till here, then you are switching back to main thread, and main thread is executing its iteration, first iteration, and displaying the value of I as 5. Then again from main thread is suspended for half a second. So uh, again the CPU switches to the child thread. And child thread will start iteration of that for loop and display 5 and 4, right? And then you'll come back to main thread. Main thread is executing one more iteration 4. Then you're coming back to child thread and completing two iterations of child thread with its next values. After 5 4 it is executing 3 and 2. Then again switching back to main thread, and main thread is completing one iteration, that is 3. Earlier it has completed 5 and 4 here, so now it is completing 3. Then switch back to child thread. Child thread is completing its last iteration 1 and displaying exiting child thread. After child thread is exited, so there is no more threads available, so it will switch back to the main thread, and main thread will complete its two iterations, 2 and 1 that are remaining, and it will also exit. So this is how uh, two threads are switching from one another. First
Sir,
main thread is using, yeah.
hello.
Hello.
సార్ ఇందాక అవుట్పుట్ ఒకసారి చూపిస్తారా?
Mm.
సార్ అవుట్పుట్ లో చైల్డ్ థ్రెడ్ మెయిన్ థ్రెడ్ అంటే వన్ ఆఫ్టర్ ఒకటి ఎగ్జిక్యూట్ అవుద్ది అన్నారు కదా సార్, మెయిన్ థ్రెడ్ చైల్డ్ థ్రెడ్ అని. మళ్ళీ చైల్డ్ థ్రెడ్ ఒకసారి టూ ఎందుకు ఎగ్జిక్యూట్ అయ్యాయి సార్?
See, we are suspending child thread for only half a second. Main thread, we are suspending it for 1000 milliseconds. Why we are doing so is uh, always the parent thread must exit last. Okay, the parent thread, main is the parent thread, right? It is the one which is creating the child thread demo thread. So main is parent thread, and the child thread is nothing but the I'll write here instead of here. I'll write what is the parent thread? Main thread, right? Parent
Yes.
thread is nothing but the main thread. And what is the child thread? Demo thread, right?
Yes, sir.
Demo thread is a child thread. So from main thread, demo thread is created. That means main thread has given birth to demo thread. So before main child thread exits, main thread cannot exit, because if main thread exits, automatically child thread also will exit, because main is a parent for child thread. That is the concept. Even before child thread has completed its execution, if the main thread is exiting, then automatically child thread also will be forced to exit without completing its operation. So then your program will not give the complete output, right? You have created a new thread to perform a particular operation, but even before that operation is completed, if the main thread is exiting, and as a result child thread also will exit, so what will happen? Will the operation that is assigned to child thread will be completed? It will not be completed, right? So that is the reason why we need to ensure that the main thread will exit only after all the child threads have completed their operation. Only after child thread exits, the main thread has to exit. Otherwise, the operations being performed by the child thread, if they are in the middle of their operation, and if main thread is exiting, then automatically all the child threads also will exit without completing their operations. So that's the reason why we need to ensure the main thread will exit last. So to do so, what we have done in our program is we are suspending main thread for more time, that is for 1000 milliseconds. Instead of suspending the child thread equal to 500 milliseconds or less than 500 milliseconds, which will make the main thread exit first, right? So to ensure it may not exactly happen in the same way, but to see that it will not happen always the same way. So to see that even if it happens, the main thread is going to exit last. So that is the reason why we are suspending the child thread only for half a second. So, and hence you are seeing in the output the child thread is completing more iterations for every switch. Main thread is when we are switching to main thread is completing only one iteration, and child thread, when it is switched back to child thread, it is completing two iterations because it is not being suspended for more time. It is suspended for less time, right? So it is so that is the reason it is in getting a chance to execute more iterations than the main thread. When you switch back to main thread, again main thread is executing only one iteration, right? And it is and it is again switching back after it is getting suspended for 1000 milliseconds. Again we are switching to child thread. Child thread is completing two iterations. So that is the reason why the main thread is executing only one iteration and child thread is executing two iterations for every one iteration of main thread. So that is how child thread is completing first and then main thread is completing last. We are manually in our program, by writing the code, we are ensuring that the main thread is exiting last. But practically speaking, this is not the right solution. We don't know how much time the child thread will spend in its execution for a particular single instruction or multiple instructions that are part of the run method of the child thread, right? So there is another alternative for coming up with a more efficient solution. So that also we'll see in the coming classes by using the join method, wait method, all these methods. So we are going to find a better solution than this one. Here we are not. It is a pure luck. By suspending the threads for 500 milliseconds and 1000 milliseconds, it will not guarantee that the child thread will complete its operation in real time scenario. In this program it may work, but in all the programs it may not work. We don't know for how much time the child thread is going to be executed, or what is the time required for the child thread to complete its operation, right? So in real time application, what is the child thread going to do? It is going to perform a very, say, complex operation, and you may not expect that operation to be completed within a given specific time. It may take more time also. So this concept of suspending the child thread for less time so that we can guarantee the main thread will exit last, it may not work in real time applications, right? So that is a disadvantage by calling the sleep method. So instead of calling the sleep method, we'll go for another alternative methods the coming program. But for your understanding and to say, to know that there is one alternative method called sleep method, which using which we can suspend a thread, just for that sake we are using this sleep method here. So later we are going to uh, use alternative methods there. Okay.
Okay, sir.
Then this is creating of single thread. So in the same way we can create multiple threads also. Multiple threads in the sense, apart from the first child thread, we can also create two more child threads. Now look at this one. In the previous program, we have created a second thread. After the main thread, we have created a second thread. Now in this program, what we are going to do is, after the main thread, we are going to create three more threads. So the code will look similar almost. Here also I am creating a new thread class and implementing same runnable interface. This time additionally I am creating a string reference variable called name, and the thread reference variable t as we have done in the previous program, and the new thread constructor. And first we are going to pass a parameter to this constructor, new thread constructor, to give a name for the newly created thread. So whenever you create a new thread here in the main method, instead of simply calling the default constructor, now we are making a parameterized constructor and passing one string parameter. Okay, so for each object that you're creating, new thread that you're creating here, you are passing one string parameter, so which will be assigned as the name for the thread that you're creating by creating this instance, right? So for the first thread we are passing 1, second thread you're passing 2, and third thread you're passing 3, and the try method will have only the sleep method, which is being the main method suspending the main thread for 10,000 milliseconds, and at the end you have the main thread exiting. So everything is same except that this try block does not have any for loop. Okay, and coming to child threads, uh, the new thread constructor receives for the first thread it receives 1 as parameter, so that 1 will be stored in this string variable thread name, and the same 1 value will be assigned to the name string variable that we created here, right? Then now we are instantiating this thread object here, t is equal to new, the thread constructor, this keyword. This keyword refers to the first object, that is 1, right? And we are assigning a name, which is the value of the name uh, string variable, that is nothing but 1, right? So when you display this in threads information, new thread, it is going to display the thread name as 1, thread priority as 5, default priority, and the thread group as main. Then you are making a call to the start method, right? And start method will in turn will call run method. So after starting this thread, again you may switch back to the main thread, and in the main thread what is going to happen is the main thread is creating another thread instance, this time with name 2. So this also will repeat the same operation here. The constructor gets executed, another second thread is created, and its name is assigned as 2, and its information will be displayed as thread 2, default priority 5, and group as main, and it will start its execution. Similarly, third thread also will start its execution. So now switching will take place between 4 threads: main thread, thread 1, thread 2, and thread 3. So there are totally 4 threads are there. Switching will be taking place among all these ones. And in the try block in the run method, we have the for loop for all the 3 newly created threads. So the for loop will display the value of I, and we are suspending each thread for 1000 milliseconds, right? So when you execute this program, let me save this first. See, 4 threads. First, we'll start with main thread, and main thread will not display any information. It will give birth to the thread 1. So, thread 1 will display its information first with its constructor, thread 1, and its priority 5 and group main. Then, next thread 2 also is displayed. Then, again, you'll switch back to thread 1, and 1 will complete its first iteration and display 5. Then, you'll switch back to third thread. Third thread is created and its information is displayed. And then you'll switch back to thread 2, and 2 will display 5. Then from 2 you will switch to 3. 3 will display 5, and from 3 again back to 1. 1 will display 4, and from 1 again you are switching to 3 instead of 2, right? So 3 will display 4 again, and then back to 2. 2 will display 4. 2 will continue one more iteration and complete 3. Then you'll switch to 3 and complete 3, and then switch to 1 and complete 3. And again, no switching. 1 will complete one more iteration and then switch to 2. 2 will complete another iteration with 2, then to 3 and complete its iteration 2, then again to 1. 1 will complete last iteration, and 3 will complete its last iteration, and 2 also will complete its last iteration. After that, you will switch back to 1, and 1 will display its exiting message. And then from 1 to 3, 3 will also display its exiting message and exit. And then switch to 2, 2 also will exit. And then finally, main thread will exit. So you cannot say from which thread you are going to switch to another thread. From main thread, you may switch to 1, and then from 1 to back again main, or you may go to 2, you may go to 3. So in that way, switching will take place. It doesn't depend on our program that we have written. So depending on the CPU scheduling and all, so switching will take place. Even though we give equal suspension time for all the child threads, the switching may not take place exactly in a sequence. It may happen in any order. From 1, it may switch to 2, and directly without 2, it may switch to 3 and back to main, and then after from main, it may go to again, instead of going to 1, it may go back to 3 again, right? So in any order, it may switch. So initially, what is the order in which the threads have been created? First, main thread has created child thread 1. Then it has created child thread 2. And even before child thread 3 is created, we are switching back to thread 1 and completing its first iteration. Then after that, the third thread is created. Then from third thread, you are going to 2. And from 2, because from 3 we have switched to 2, it is not mandatory to go back to 1 again. So it is going back to 3 again. And from 3, it is going to 1. And again from 1, instead of going to 2, it is going to 3 again. And after that, after 3, switching to 2, and 2 is completing 2 iterations, right? So it depends, because you may be switching to from 3, you may be you may not be switching to 1 or something to go directly. You may be switching to main thread, because main thread is suspended for more time. You may switch back to 2, and 2 may complete its 2 iterations. So it all depends internally on the hardware of your CPU. Fine, but we need to write the program in such a way that uh, multiple threads are created, and controlling switching between different threads is not in our hands. So if you want to make them control, if you want to control them, we'll see some other methods in the coming classes. Using those methods, we can switch as per our requirement, but we cannot completely take a control on when to switch from one thread to another thread. Okay, so this is creating multiple threads. Hello.
ఎస్ సార్. హలో
Understood?
సార్, కొంచెం డౌట్ ఉంది సార్. నేను రేపు పొద్దున అడగచ్చా సార్ డౌట్స్?
Yeah. ఇప్పుడు ఏమన్నా వర్క్ ఉందా?
ఇప్పుడు ఒకసారి మళ్ళీ ఒకసారి మొత్తం వీడియో చూసి నోట్స్ రాసుకుంటాను సార్, అప్పుడు అర్థమవుతుంది.
ఓకే. ఓకే. So now let me show you one more example. Instead of using those for loops and all, we'll write a program in such a way that uh, we'll create the main method. Two threads I'm going to create. Okay, but for creating two different threads, I'm creating two classes which are implementing runnable interfaces. See, this is new thread class which is implementing runnable interface, and this is new thread 1 class which is also implementing runnable interface. And in this new thread class, the same string variable name is created, an integer variable value, uh, another integer variable result which is initialized with 1. Thread reference variable t is created. New thread constructor is defined, and it receives two parameters this time. One string parameter and second one is integer parameter. So this integer parameter n is nothing but the name of the string. So we'll assign this to n, and the integer m value will assign it to the value variable here, right? And then we'll instantiate the thread with this keyword and the name. So whatever name you are going to give the first thread, so that you are going to, so what is that? Factorial, and you are passing 5 as parameter to the constructor. Okay, so uh, the name will be assigned as factorial and value m will be assigned as 5 to the value variable. So after instantiating the thread, you will display the information about the newly created thread, and then you will make a call to the start method. Start method will in turn call run method. In the run method inside the try block, what I'm doing is I'm calculating the, look at the logic for int I equal to 1, I less than or equal to value I plus plus. So I value is value is 5. So this for loop will repeat for 5 times. Each time it is repeated. What we are doing is we are checking, we are modular dividing I with 2. So that means what, if the remainder is 0, it indicates that it is an even number, otherwise it is a odd number. So this is going to display if it is an even number. If it is an odd number, it is not going to display. So this logic is for displaying all the even numbers. And when you are displaying those even numbers, after displaying one value, you are suspending the thread for half a second. Right? Fine. Then catch block is displayed, and then after that, the thread that we created with whatever name, that thread will be exiting. This is for even class, and for factorial class also same logic, same name is assigned, value is assigned. It will start its method, and then run method will start. Run method will have the logic for finding the factorial. So for loop is iterated 5 times, and we have already assigned result variable with value 1 there. So result star is equal to I means result is equal to result into I. So this is going to compute the factorial value. And If I is equal to value, that means 5, system.out.println factorial is equal to concatenated with result. So when the value of I will be equal to value, only when it becomes 5. So after it becomes 5, the value factorial value is displayed, and uh, then only this if statement system.out.println will be executed, right? Otherwise, after every iteration, this is suspended for 10 milliseconds, and then you'll display a message exiting for this thread also. So two classes we are creating. One is new thread class, which is implementing runnable interface. It has a new thread constructor. For this, we need to pass two parameters. One is the name of the thread. Second one is the value for which you want to find factorial. And similarly, second class also with its name new thread one, this is also implementing runnable interface. And the constructor has two parameters. One is the name of the thread, and second one is the value up to which you need to find all the list of even numbers. Okay, so the first one is going to display or find out the factorial of a given number, and second one is going to display all the even numbers up to that particular value. So when you run this program, the switching will take place between the main thread and even numbers thread and factorial thread. So totally three threads are there, right? First one is main thread. So by default, you'll have in every program this main thread, and then main thread is going to give birth to new child threads. First thread is factorial thread. Second thread name is even numbers thread. Right? Factorial will be found for 5, and even numbers will be found up to 10. That means all the list of even numbers up to 10 will be displayed. So if you run this program, then you can see the output. See, new thread, first thread is created with its name is factorial, and new thread even numbers. Then you're displaying factorial value as 120, and factorial exited, and after that even thread is displaying 2, 4, 6, 8, 10. Then after that even numbers exiting, and then finally main is exiting. And look at the way how the thread names are displayed: new thread, factorial, new thread, even numbers. Why this is happening so? Because in our threads we are simply displaying only the thread name by using this name variable. We are not using the object t. If you use the object t, it will display its name directly name. So instead of using name variable here, we can use p dot get name, right? So that is another way using which you can display the name of the thread. So just like here, you can also do it even here also. Instead of t, instead of name, you can use p dot get name. So same output you will get, you will not have any change because you are getting only the names of the thread. We use instead of name, if we use t here, only t, and here also instead of dot get name. If you use only T, then you'll get the complete thread information. So if you observe, factorial is being exited very even before child thread starts its first iteration, right, in this program. So if you look at the uh, run method for factorial, we are suspending the thread only for 10 milliseconds, right? Say I suspend it for 1000 milliseconds. Main thread, how much time I'm suspending? 10,000 milliseconds. Let's see if some change happens. Now what is happening? Factorial thread information is displayed, then even number thread information is displayed. After that, even number are started displaying 2, 4, 6, 8, and then in switching to factorial 120, and then back to even, displaying the last even number, and then factorial is exiting, and then even numbers is exiting, main is exiting. Why this is happening like this means because during factorial iteration, during every iteration, you are not going to display the factorial value, right? You are going to display the factorial value only after the last iteration is completed at the end. But coming to even numbers, the even numbers will be displayed for every iteration, right? So that's the reason why you are noticing this factorial here now, even before 2, 4, 6, 8. But earlier, because factorial was suspended only for 10 milliseconds, which is very small when compared with 1000 milliseconds or 500 milliseconds. So factorial is completing its iteration faster, even before the first iteration begins for the even numbers, right? So when you make a change to the program, then you will get like this. So depending on how much time you are suspending that thread, the switching will vary. But main thread must be given more time. It must be suspended for more time than compared with the two child threads always, right? So that the main thread will not exit before the child threads. Okay, understood?
Yes, sir.
Tomorrow you can ask your doubts. If you want, I'll send this program.
Sir, yes, sir. Both the programs, sir. Previous one also.
Programs I'll send.
Yeah, okay, sir.
Right. We'll meet tomorrow one.
Okay, sir.